Hello, welcome to 21.1. Now, when we started quantum mechanics, we needed a quantum size unit to measure energy with, and we have one, the electron volt. 1 electron volt is equal to 1.6 times 10 to the negative 19 joules. So, in other words, 1 electron volt is equal to, let's see, 1, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, la 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 la. It goes on for a very long time. I'm not writing it, okay? It's a lot of zeros. It would be decimal, 18 zeros, 1, 6. That's how many joules we're talking about. These are very, very smart, very, very small numbers. So what I'd like to figure out, just for the heck of it, how much energy do I use every day in electron volts? So my total energy usage in a course of a day is 13,700,000 joules. Now, in order to get this in electron volts, I'm going to have to divide my number by 1.6 times 10 to the negative 19. Now, I could do this long ways, but there'd be a hell of a lot of zeros and a lot of opportunities to make a mistake. But I could also do it in scientific notation. Now, this is a classic example why you want to use scientific notation. It's going to make it a lot simpler. So, 1.3 times 10. So, in order to put this in scientific notation, I'm going to move the decimal point 1, 2, 3, 4, 5, 6, 7 places. So this is going to become 1.37, and so I moved it 7 places, so that'll become times 10 to the 7th. Now we have a much easier formula to work with. So 1.37 divided by 1.6 is equal to 0.856 blah 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 blah. 10 to the 7th plus 19. Now this is on the denominator, so it's minus negative 19. Minus negative 19 is plus 19. So it's 10 to the 26th. That is a lot easier. You're going to have you're not going to screw up 7 plus 19. You're just not going to mess it up. It's a lot less likely you're going to have a mistake. Now, by the way, scientific notation, we always want the decimal on the other side of the first number, right after the first number. So we move it over one place. We get 8.56 times 10. Now, by the way, this got a little bit bigger. This got one place bigger. So this is going to have to get one place smaller. There is our answer. 8.56 times 10 to the 25th electron volts. Now, if you did this long ways and you didn't screw up, well, what are you going to get? Well, I'll tell you what you're going to get. I'm going to write it right here. 8, 5, okay, 6, 0, 0, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, hold on a second, 3, 6, 9, 12, 15, 21, 24, yep, there we are, that many electron volts. The chances of messing that up, losing a zero, are big, and if you lose a zero, you're off by an order of magnitude. So please, 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 use your scientific notation. It is actually there to make your lives easier. But yes, needless to say, electron volts, they're very small. I'm an active person. I ain't going to measure my total energy use in electron volts anytime soon. But you can. It's just a unit. I could measure it in kilowatt hours if you wanted. It'd be about 4. I could measure it in calories. I don't want to say how much that is. But anyway, that is my energy in electron volts. By the way, if you're not as big or as active as me, you're going to get a smaller number. It's still going to be a huge number, but it'll be smaller than this. Thank you. Have a nice afternoon.